Okay, hello, this is Mr. G. We will be talking about magnetic force and energy today. So, first, we are going to do our warm up, which is I want you to open the simulation. I've opened the simulation, and I am going to show our field lines. First, just looking at the field lines and the direction of the magnets, will these magnets attract or repel? If you said repel, very good, you're correct. They repel. But now I want to hit analyze, and I want to analyze the type of energy that is going on in this magnetic system. And I want you to write down what you observe or what you notice about this system. So this is the potential energy. This is the kinetic energy. I want you to notice what happens. Okay, what did you notice happened to the potential energy? What did you notice happened to the kinetic energy? Very good. The potential energy decreased and the kinetic energy increased. Today we are looking at where did the energy to move magnets come from? Our first question is, how can magnets cause objects to have kinetic energy? Write down the question now. Remember, a magnetic force can attract or repel an object at a distance. Magnetism is a force caused by the unified movement of electric charges. So in an atom, we have these electrons on the outside. These electrons are moving around this atom really quickly. When the electrons are moving, it's causing magnetism to happen. So in a magnet, all of the electrons spinning around this magnet are moving in a unified way from north to south pole, causing magnetism to happen. We can see this in this simulation. We have a magnet. The magnet's electrons are moving unifiedly from south to north inside the magnet. When they get to the outside of the magnet, they move north to south around the magnet in a unified direction. This is causing magnetism to happen, which is causing the compass to move. And you can see the magnetic field lines around it. When the electrons are moving in a unified direction, it causes energy to happen. Energy is the ability to make things move or to change. Kinetic energy is the energy that an object has because it is moving. So the magnetic field and the spinning electrons moving around the magnet can cause magnetism to happen, which can attract or repel objects. When an object is attracted to a magnet or repelled from a magnet, it has kinetic energy. So when we transfer an object, which means to move from one object to another or one place to another, in order to transfer one from one place to another, it has to have kinetic energy caused by magnetism. The key concept here, a magnetic force can move an object with kinetic energy. Let's exit out of the slideshow and let's go back to the simulation. When I go to the simulation, I have two magnets. I have two magnets. My first experiment, I want to test if I put two weak magnets next to each other, what will the strength of their potential energy be? When I hit run, they'll push away from each other. And I hit analyze, the amount of kinetic energy produced was 239 joules. When I go back to building and I get rid of these, and I put two bar magnets together that are stronger, same distance apart, and I hit run, they have 663 joules of kinetic energy. That is a much larger choice. So the key concept here is that stronger magnets can cause greater kinetic energy. Stronger magnets can cause greater kinetic energy. And remember, a magnetic force can cause an object to move with kinetic energy. And the closer or stronger it is, the more kinetic energy it will have. Where does the kinetic energy come from? Write this question down. Potential energy is the energy that is stored in an object or a system. In magnets, the energy used to move a magnet against a magnetic force is stored as potential energy in the magnetic field. So when I go back to my simulation, you can see in my simulation all of this potential energy. Potential energy is the potential for an object to move, and it's stored in magnetic fields flying around the magnets. It's stored in the magnetic fields surrounding the magnet. So when I put two magnets closer together, there's a lot of potential energy stored, 7,832. And as these magnets get further and further away, their magnetic fields are getting further and further away, which means there's less potential energy stored in the system. So when they get closer, there's greater potential energy. When they get further away, there's less potential energy. When they get closer, there's more potential energy. When they get further away, there's less potential energy. The key concept is that there is greater potential energy when there are stronger or closer magnetic field lines. The potential energy for the magnet is stored in these magnetic fields. So how can magnets cause an object change an object's energy? Convert means to change from one type to another. So we convert from potential energy to kinetic energy. A magnet can convert potential energy to change into kinetic energy. The key concept, a magnetic force can convert potential energy stored in a magnetic field to kinetic energy in the magnet. So, energy is not being created or destroyed, it's just changing. So the potential energy stored in the magnetic field lines is stored as a high amount of potential energy. And as these magnets push away from each other, the potential energy is turned into kinetic energy. The potential energy, as you can see on the graph, is changed into kinetic energy. We can do this very same with a rotated magnet. As they attract to one another, we have a lot of potential energy. And the potential energy will be changed into kinetic energy as the objects move faster and faster and faster until they connect and all of their energy is turned into kinetic energy, movement, and then it'll become potential again. Potential, 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 kinetic. So let's do some review questions, some practice questions. In a computer simulation, Jeffrey moves a magnet toward the other magnet that cannot move. What happens to the potential energy in the system of magnets? Charisse sets identical magnetic carts on 2 tracks. At the end of each track is a blue magnet that cannot move. Charisse can move the carts one space to the left or one space to the right. Which movement will result in the largest increase in potential energy? Moving this magnet one left or this magnet one left or right? Boom or boom. Abdul moves a magnetic toy train away from a magnet that cannot move. What happens to the potential energy in the system of magnets during the movement? So he moves this train car from here to here. What happens to the potential energy? An engineer is investigating potential energy with 2 identical magnetic roller coaster cars on different sides of a center magnet that cannot move. To test her ideas, the engineer will move one car one space. Which movement will result in the largest increase in potential energy? Moving this block closer or this block closer? A spaceship is traveling through space. Suddenly, its speed increases. What can you say about the kinetic energy of the spaceship? What happens to the energy in a system of magnets when the magnetic force causes 2 magnets to move? Thank you. That's chapter 2. Please enjoy the video and have a good day.